Hi guys, today we're going to move into some more complicated differentiation, and I want to look at how we might differentiate something like x squared sine x. Now this is called the product rule because it's the product of two functions. So you get your x squared function and your sine function and you're multiplying them together, and that's what we're thinking about when we're thinking about product. Now I want to think about a general form. I'm going to call this y equals uv. So u equals x squared. And I like to work as a side note when I'm doing anything like this. So along my way of doing this, I'm going to differentiate that. So I get du by dx is equal to 2x. And my v here is sine x, and it wouldn't matter if you chose them the other way around because multiplication is commutative, it can be done in any order. So sine x, x squared is exactly the same function as x squared sine x, but v equals sine x and dv by dx, the differential of sine x with respect to x is cos x. So once we find out those 4 bits, we're in a position to be able to work on one of these examples. So what I haven't told you is the general rule, which is that dy by dx is equal to u dv by dx plus v du by dx. And all I now have to do is put my bits into that equation. So it was a really useful thing to do to work out those bits as well. So u is x squared, dv by dx is cos x, plus v is sine x, and du by dx is times 2x. Okay? Now you might see it simplified somewhere. If you can take out a common factor, you might see something like x cos x plus 2 sine x. You don't necessarily have to take that step. So, like I say, useful to have this side workings out going, and I really would recommend that you have an area where you do your main problem and a side area where you work out some more of the problem. Just let's have a look at something else. Y equals e to the x times x cubed plus x to the 4. Now essentially that looks quite complicated. So I've got y equals uv, so u equals e to the x, du by dx, also equal to e to the x, my favourite differential. V is equal to x cubed plus x to the 4. Now the reason I've chosen this is because you clearly have to use the chain rule when you're differentiating that. So I'm going to differentiate the outer function. So that's 4x cubed plus x cubed. And then I'm going to times by the differential of the inner function, 3x squared plus 1. So there's my side workings out. My next step underneath here, always write out the formula. It will give you the structure and the organisation that you need. Number 1 tip, just as my number 1 tip with mechanics is draw the diagram. Anything like this where you're using a formula, you write it down every single time because it gives you the format, and the format is so important. So I've got u dv by dx. So I'm going to write that as so it's e to the x times 4 lots of this. So I'm going to put 4e to the x. I think that's a bit neater. 4e to the x cubed plus x cubed 3x squared plus 1 plus v, which is x cubed plus x to the 4 times du by dx, which is e to the x. And you might be asked to look for some common factors within that. I can see a common factor of e to the x. I've also got a common factor of that cubed, because this is that cubed times that. So I'm going to take that out, x cubed plus x cubed, and that will leave me with 3x squared plus 1 plus x cubed plus x. Because obviously if I x cubed plus x cubed times x cubed plus x would give me x cubed plus x to the 4. So that's right, I know that I'm right, okay there. And there might be a final step of the simplification, of the factorisation there, to say that we've got e to the x cubed plus x cubed times x cubed plus 3x squared plus x plus 1. And if that factorises, we may have something else on our hands too. I can't see that it does offhand, but it may well do. But I think that would be sufficient as a final answer. Okay, so the basics are: find your u and your v as your two separate functions, differentiate them, put them in a formula to get your answer, and if there's any common factorizations, do it. You'll get most of your marks for getting to here, but particularly on something where you've got big polynomials involved, think about common factors that you can pull out. And especially what I did with this power here, taking an x cubed out of this function takes all that out completely, but if I take an x cubed out of this function, it leaves me just one of them left because I've got 4 overall. Okay.